Well, dear my students, now I am starting new topic in AC, alternating current. Till now I defined definition of current, then I told you how to measure alternating current and alternating voltage, principle involved of measuring AC, and then I defined root mean square value of AC, etc. Now we will study the behavior of different circuits. Actually, in AC, the current through which we can pass are three devices. Conductor, जिसको हम resistor कहते हैं, inductor, solenoid, inductor, capacitor. What is the behavior of these three elements separately, and inductor? How does inductor behave? What inductor? A solenoid or any coil forming the form coil, and capacitor. How do they behave? I have written the topic here: AC circuit containing resistance only. Different will give different heading. Like our NCERT book has given the name AC voltage applied across resistance. Then what will be the current and etc. So, but my aim here is to understand behavior, how the current will flow, and what is the behavior of resistance for AC. But resistance in general behave the same way as in DC, but there is something other. So let in figure a conductor of resistance R is connected across an AC supply. The instantaneous voltage of source is V equal to V0 sine omega t. I am going to explain you something which you can't imagine. The such type of thing we have to learn. V equal to V0 sine omega t. It is time varying voltage, periodically varying, मैंने बताया था. Now the source voltage across AB is equal to the potential difference across points A and B is the same across CD. So current in circuit, current Ohm's law is valid here also, na? From Ohm's law, O capital होना चाहिए. Ohm's law, I is equal to V by R, but V is by equation 1 V0 sin omega t, or I is equal to V0 upon R sin omega t, as V equal to V0 sin omega t. Sin omega t is a number, so V0 upon R should be dimensional current, and we write it as I equal to I0 sin omega t. I0 here, V0 by R is equal to peak value. Of current, maximum value. What is important here to understand? 2 and 1. I0, V0, which is peak value voltage, peak value current. Omega T, sine है दोनों. You know, in case of sine, if value of omega t यानी कि theta vary from 0 to 180 degree. So sine theta is plus always positive. Value will vary by 45, sine 41 by root 2, sine 31 by 2, sine 120 root 3 by 2, like that. So, but all positive. But when theta vary from 180 to 360, for sine negative. And we have learned vectors. So if left to right direction positive, so right to left negative. And in class 11 you have learned y equal to a sine omega t is the equation of displacement, and this omega t will tell the direction of y. Similarly here omega t will tell the direction of I and current, which are same. This omega t here is called phase. Phase, we have learned phase. Phase is that physical quantity which gives the direction only, positive or negative or something other. मान लो मैंने कहा भाई I equal to I0 sin omega t plus pi by 4. pi by 4 में 45 डिग्री. अगर मेरा ये I along x axis मान लेता हूँ, हैं, ये मान लो I डैश है, एक I था, I equal to I0 sin omega t. तो if I take I this, then I dash 45 degree. So that is determined by this value only. So in figure 1 and 2, omega t is called phase, and we find here. We can write now. I think you have got my point. From equation 1 and 2, equation 1 and 2, we get. Yeah, we can say that potential difference across इनके voltage across conductor and we can say that potential conductor and current through it are in same phase. Same phase means when V positive, I positive. When V zero, I वो तो अलग चीज है. But positive और negative का मतलब है phase, direction. Means they are in same direction. So we can represent it how? Suppose I represent I this direction. So current will be, thus voltage VR will be the same. You might think that it always happen. No, it does not always happen. It does not happen always. I mean, only in case of in a circuit. This is a case of a circuit. Only current and voltage are in same phase only when there is resistance. Means what is the direction of voltage? The same as that of current. Suppose I write XY. I call it phasor diagram. In books actually they have started different, but they come later on this diagram. तो ये इक्वेशन ये ग्राफ क्या कर रहा है? It's called phasor diagram. Here V equal to V0 sin omega t and I equal to I0 sin omega t. If I plot the two on same graph for t by 4, t by 2 for one cycle, 3t by 4 and t. Suppose I0 is this much minus I0. V0 दिस मच, इसके एरिया अलग अलग है भाई। तो T इक्वल टू 0 पे वोल्टेज 0, करंट भी 0। T इक्वल टू इसको लिखा ना V0 साइन 2 पाई 3 टू T, अगर मैं T/4 पाई बाई 2, करंट मैक्सिमम, ये मैक्सिमम, यहाँ दोनों T/2 पर दोनों 0, यहाँ दोनों मैक्सिमम इन अ कोई डायरेक्शन एंड 0। तो दिस इज अ ग्राफ फॉर करंट, द ग्राफ फॉर वोल्टेज द सेम। तो when current positive, voltage positive, when current negative, voltage negative. This is the meaning of that current and voltage are in same phase. But I told you this is true only in case of resistance only. This fact is true only in case of resistance only. Now I will take next example. Please adhere to this diagram. Try to understand what I am saying. In case of circuit containing pure resistance, conductor. Actually conductor here is called resistance. We start saying resistance. Now I write heading AC circuit. Containing pure inductor. Pure inductor. Inductor, what is inductor? A solenoid or any conductor in the form of coil. Maybe like this or maybe like this solenoid. But we represent inductor by symbol. The symbol of inductor is this. Unit of inductance. Do you remember Henry? L, inductance, coefficient inductance. L, pure inductor. Why I am talking pure inductor? But every solenoid, every conducting wire has resistance. So I will not consider resistance here. If it is a pure inductor and we pass, suppose say 10 ampere current, potential difference V equal to IR होता है, लेकिन आज का है तो कीजिए, if we pass direct current through inductor, initially there will be a potential, but after some time potential becomes 0, there is no resistance. What is that? That is due to self induction. When current start growing, so there will appear potential difference only. Suppose this is the voltage V बराबर V0 sin omega t. So you know this voltage will vary, current will also grow. So figure shows a pure inductor of inductance L across an AC source whose voltage is given by V equal to V0 sin omega t. If I is the current at an instant and growing current, then potential difference across that V equal to minus L di over dt. So minus dl L di over dt back EMF. It is back EMF here. This is called back EMF. So this back EMF and this V are equal and opposite, and hence we can write here L di over dt is equal to this voltage source, or if I generally write minus L di over dt plus B equal to 0. Algebraic, this is called Kirchhoff's law. Or you can write here कि L di over dt equal to V, or V means क्या भाई? V 0 sin omega t. V 0 sin omega t. Or it is di upon dt V 0 upon L sin omega t, or di is equal to V 0 upon L sin omega t dt. L, what is L? Coefficient of induction, self-induction. Now to be integrated, so I will be integration V0 upon L sin omega t dt. Or it is I equal to V0 upon L or into 1 upon minus omega cos omega t plus C. So you can write I equal to V0 upon minus omega L cos omega t plus C. C here constant of integration. In mathematics, C is called here constant of integration. Now, constant means that which does not change, but in a circuit current is always changing, so constant term does not exist. In AC circuit, constant term does not exist. Whatsoever is there, whether it is current or voltage, they are varying with time, so C is 0. And hence our equation comes out I equal to, I write V0 upon omega L. ये C0 होगा और इट इज रिटन है साइन ओमेगा t माइनस पाई बाय 2. ओमेगा है, सॉरी. I equal to V0 upon omega L और साइन omega t minus pi by 2. Now you may say कि why it is so, but this term is cos omega minus cos omega t. Sin 90 plus theta minus theta, नहीं plus theta equal to cos theta होता है, but it is minus, so sin you can write how? sin 90 plus theta cos theta, और sin minus theta is equal to minus sin theta. Sin minus theta, तो due to that, सॉरी उल्टा लेंगे हम, सॉरी एक मिनट, हमारा है cos 90 plus theta is equal to, please, cos 90 minus theta is equal to sin theta, but it is minus cos 90 minus theta, तो क्या लेंगे हम इसको? साइन प्लस लिख लिया, प्लस साइन cos 90 प्लस थीटा साइन थीटा माइनस साइन थीटा, नहीं बनने के बाद ऐसे नहीं भाई, सॉरी, 1 मिनट भाई, मुझे थोड़ा कुछ हो गया। इट इज माइनस कोस ओमेगा टी, तो आई राइट हियर साइन माइनस 90 प्लस थीटा, तो इट इज इक्वल टू माइनस साइन 90 प्लस थीटा इक्वल टू कोस थीटा, इक्वल टू माइनस cos theta because of this fact. Yes. So this equation can be written as this one. Here, this is number. So V0 upon omega L is dimensionally current. Now here V0 upon omega L is equal to I0. ये equation 2. And as equation can be I equal to I0 sin omega t minus pi by 2. ये equation 3. Equation और हमारी है, तो from 1 and 2 ये 1 थी हमारी sin omega t, voltage V equal to V0 sin omega t. From 1 and 2 we find that 1 and 3, sorry. From equation 1 and 3 we find that current in circuit containing pure inductor lags behind the voltage by pi by 2. ना भाई, वीडियो थोड़ा लंबा हो गया। एंड व्हाट डज इट मीन कि ऑन फेज डायग्राम इट इज आई, इट इज वी एल, potential wave inductor 90 degree. It is like that. If I say current in the east, then voltage in the north. Then voltage in the north. Now, is that clear? And I will plot the graph also. Other. Now from equation 2. V0 upon I0 is equal to omega L. V0 upon I0 is dimension equal to resistance, but we have taken pure inductor. Resistance not is there. So this term here V0 upon I0 is called inductive reactance. Inductive reactance denoted by XL, suffix L. So XL is equal to omega L. XL is equal to omega L or equal to 2 pi L. यानी कि what is inductive reactance? Equivalent to resistance due to ohm, and it's the property of inductor to oppose flow of alternating current. If current is DC, omega 0, F 0, to XL 0. So if we plot a graph between F and XL for given inductor, it will become like this. Suppose L1 के लिए, for L2 के लिए, here L2 greater than L1. So inductor behave like bad conductor for high frequency current and good conductor for low frequency current, and we use this property. Now here voltage was V0 sin omega t and current I was I0 sin omega t minus pi by 2. ये तो फेजर डायग्राम होगा. If you plot graph between T/4, T/2, 3/4, T equal to 0 पर V0 and this curve will come for voltage V के लिए I T equal to 0 sin minus pi/2 यानी कि माइनस I0. मान लो I0 यहाँ तक तो ये V0 यहाँ है, माइनस V0 यहाँ है, तो इट कम लाइक दिस. Current graph will be like this. This is for I, this is for V. There is a time lag of T/4 between current maximum and voltage maximum. Time lag T/4. Phase difference 90 degree. Thank you. मिलते हैं वीडियो में.